All right, so get this. Imagine a universe with like two objects that are exactly the same, like exactly down to the very last atom. Would you even be able to tell them apart?
Whoa, that's a question that takes us straight to the identity of indiscernibles, a principle that's been, debated for centuries in philosophy.
Centuries. Wow. Okay, that's heavy.
Luckily, we've got this excerpt here from the Stanford Encyclopedia of Philosophy. It's going to be our guide, through all this.
Perfect. I think I'm going to need it. This sounds like a real brain twister. So what is this identity of indiscernibles all about?
Okay, well, it's also called Leibniz's law. And basically what it says is if two things have all the same properties, they're actually the same thing.
Hmm. So if I can't find a single difference between two things,
They got to be one and the same, yep.
okay, I think I'm following. But this has got to be about more than just like two identical coffee mugs, right?
You got it. It's not just about how things look, it's really about the essence of objects or substances, I guess you could say. Like, it's saying that their identity is all tied up in their properties.
So it's getting at like what makes something unique, even if it looks exactly the same as something else.
Exactly. And to make things even more interesting, there are actually two versions of this principle. We've got the strong version and the weak version.
Okay, now you've got my attention. Strong versus weak. What's the difference?
So the strong version, that one zeroes in on intrinsic properties. Qualities that belong to the object itself, no matter what's around it.
Like,
Shape, size, composition, all that.
oh, I see. So for the strong version, it's all about what the object is, not where it is or what's around it.
Precisely. Now, the weak version, it broadens things a bit. It includes properties that might be related to other objects, but without being specific about which objects.
So like being a certain distance from something.
That's it. That would be a property under the weak version.
I think I see where this is going. It's easier to picture, say, two rocks being totally indiscernible, just based on their own properties, the strong version. But two people, that's a whole different story.
You're getting it. It's like our relationships, our experiences, our place in the world, all of that factors into what makes us unique. Even if we could, find two people who were physically identical, their lives, their connection, that would set them apart.
Yeah, that makes sense. So the weak version is almost acknowledging that everything exists in relation to, well, everything else. Like it's all like a cosmic web.
Exactly. And you know what? That leads to some pretty mind-boggling thought experiments. Like our source uses this example of three identical spheres. Just imagine them arranged at different distances from each other. Does that spatial arrangement alone make them distinct?
That's a good question. And like, if the spheres themselves are identical, does it really matter where they are in space?
And to really push the limits here, imagine a perfectly symmetrical universe with only three of these spheres, all the same distance apart. How could you even tell them apart then?
Okay, now we're getting into Matrix territory or something. Like it's a cosmic spot the difference, but there are no differences to spot.
And that's the real challenge, right? These thought experiments, they really push even the weak principle, as far as it can go. If there's just absolutely no way to tell these spheres apart, even based on how they relate to everything else in that universe, are they even really separate things?
Yeah, it makes you wonder, like, if they're truly indiscernible, does it even matter if we call them separate things? Is it all semantics at that point?
That's a really great point. And it leads to this real head scratcher, the concept of thisness. If two things are identical in every other way, does just being this one or that one, does that actually count as a property that sets them apart?
I don't know. I'm trying to wrap my head around thisness. It almost feels like we're just pointing at something and saying, well, that's that one, and this is this one. Even if there's no real difference, it feels a little circular, doesn't it?
You've hit the nail on the head. Philosophers have really wrestled with this whole thisness concept. They also call it Heischelti. And it's this idea that an object has a unique identity simply because it's that specific thing. But does relying on this really abstract notion to tell things apart, does that actually weaken the whole principle?
It definitely makes things more complicated. You're saying the identity of indiscernibles, it only works if we can point to this vague idea of thisness. It's making me think maybe it's more about our limitations, and how we observe things and understand things, than about some fundamental truth about reality itself.
Yeah, that's a valid interpretation. It really raises the question, right? Are there things out there that are truly indiscernible, even if we can't, perceive them that way?
So even if our universe isn't full of exact copies, Could they exist? I don't know, in other universes. Maybe there's like a universe out there where every grain of sand is like totally identical.
That's an intriguing thought. It highlights how tough it is to like apply this principle universally. But let's try to get a little more specific here, okay? Let's look at a thought experiment from the philosopher Max Black. So he asks us to imagine a universe with just two perfectly identical spheres.
Okay, okay, I can picture it. It's like the ultimate minimalist universe, right? Just two spheres hanging out in the void.
Now, here's where the identity defense comes in. So, some philosophers say we could reinterpret this two-sphere universe, right, as actually containing just one sphere, but in a curved space.
Hold on, wait. So instead of two separate spheres, it's like one sphere existing in multiple places at the same time. I think you're breaking my brain a little bit.
That's it. It's like the sphere is taking like this curved path through space, and it's appearing in two locations at once. It's a clever way to try to maintain that identity of indiscernibles even in this like seemingly symmetrical situation. But of course there are counter arguments.
Oh, I bet. I mean, this is philosophy, right? There's always like another layer to peel back.
Right. Okay. So, Robert Adams, another philosopher, he comes along, right? And he proposes what he calls a continuity argument. And it kind of challenges this whole interpretation. So, imagine, what if there was just the slightest difference between these two spheres? Like, say, one had a tiny scratch.
Okay, I'm picturing it a little scratch on one of the spheres. How does that change things?
Well, if we're going with this identity defense thing, the fact that that tiny scratch exists would mean that the shape of space wouldn't actually need to be curved to explain why they're separate. But that implies that like a tiny scratch could somehow like change the structure of space-time.
Whoa, that's a lot of power for a tiny scratch. Like, are we saying that just the tiniest change to an object could, like, have massive consequences for the whole universe?
Yeah, it shows just how how counterintuitive it can be to try and like force these symmetrical universes to fit with the identity of indiscernibles. And then Adams, he goes a step further with a modal argument. And this gets into the idea that the identity is like a necessary property. So think of it this way. If something is true in all possible worlds, then it's like a necessary truth.
Okay, so we're going full-on modal logic now. I'm here for it, but I might need to hold on to something.
Basically, what Adams is saying is that if it's even possible for those two spheres to be indiscernible, right? Like if we could hypothetically like erase that scratch, then it must be possible that they're actually the same sphere.
Okay, so we're playing with, like, hypotheticals now, but I can see where you're going with this. If their identity is, like, fixed and can't change, then they have to be the same, scratch or no scratch.
Exactly, but that creates a contradiction, right? Because we're assuming they're different in the first place because of the scratch. So we're back to that question. Are those seemingly identical spheres truly distinct, or are they just different versions of the same thing?
Okay, my head is officially spinning. It's like the more we try to pin down what makes something unique, the more complicated it gets.
I know, right? And just when you thought we'd reached peak mind bending, it gets even wilder. So the philosopher Michael Della Rocca, he throws out this challenge. Multiple identical spheres occupy the same space. So picture this, like 20 spheres, all totally identical, all overlapping in the same spot.
Okay, now that is just ridiculous. I mean, that's got to be physically impossible, right? Like, how can 20 spheres be in the same space? Wouldn't they just, like, I don't know, merge or something?
It does seem like totally counterintuitive. But Della Rocca's point is, if we reject this whole identity of indiscernibles thing, then how do we even explain why this scenario is impossible without like appealing to the very principle we're trying to debunk?
So it's like we're saying they can't be in the same space because they're different, but how do we even know they're different if they're identical? It's like a philosophical catch-22 or something.
Exactly. He's saying we need to be able to explain non-identity, especially when we're dealing with like simple objects without any parts. And that brings us to something called the third grade principle, which is like an even weaker version of the identity of indiscernibles.
A weaker version. How can it get weaker than the weak principle?
Well, the third grade principle, it acknowledges that even if two objects are indiscernible in every other way, right? They might still be different based on like a symmetrical but irreflexive relation.
All right, you lost me. What does symmetrical but irreflexive even mean?
Okay, so think about it like this. If object A is related to object B in a specific way, right, then object B is also related to object A in the same way. That's symmetry. But neither object can be related to itself in that way. That's irreflexivity.
Okay, okay. So going back to our two-sphere universe, each sphere is a certain distance from the other sphere, but neither sphere is that distance from itself. It's like a subtle way to make them different without actually saying there's any difference in the spheres themselves, right?
You got it. And what's so cool is that like recent work in quantum mechanics, it suggests that this third grade principle might actually be true for certain types of particles called fermions.
Wow, quantum physics is in on this now. This is getting like seriously mind-blowing.
It seems like even the smallest particles might have a way of like, asserting their individuality. It really is a deep rabbit hole.
So we've gone from like basic spheres to quantum particles. This whole deep dive into the identity of indiscernibles, I mean, it's really taken us to the edge of like what we think we know about reality, you know?
It really makes you question, right? Like, are even the things in the world that seem so solid, are they actually as unique and distinct as we think they are? It really challenges our whole idea of identity, for objects and even for ourselves.
It really makes you think, huh, if we can't even be sure what makes a simple sphere unique, then what does that say about like the whole nature of identity itself? I mean,
Yeah, it's a question that's been around forever in philosophy, and it seems like the more we learn, the more complicated it gets, It makes you wonder, what if there was another universe out there and it had like an exact duplicate of you? Would that, I don't know, would that change who you are? Would you even be able to tell which one was the original?
whoa, hold on. Okay, another me out there somewhere. Would we be the same person? Like have the same thoughts, the same experiences? This is messing with my head a little bit.
See, that's the beauty of philosophy, right? It doesn't always give us like easy answers,
Yeah.
but it makes us thinking, it makes us think critically about the world and our place in it, right? It pushes us to like look at our assumptions and maybe consider new perspectives.
So even if we don't like have all the answers, just doing these kinds of thought experiments can like help us understand ourselves and the universe, I guess, a little better.
Oh, absolutely. I mean, the identity of indiscernibles, it might seem kind of abstract, at first, but it really has implications for how we see everything, from our relationships to, I don't know, our understanding of the entire cosmos.
It's almost like this one principle just like unlocks this whole universe of questions. And each question just leads to like even more questions. It's kind of dizzying, but also like really exciting, you know.
Exactly. I mean, it reminds us that there's always more to learn, more to explore, and more to just like wonder about, right?
Well, on that note, I think I need a break from all this thinking. Maybe I'll go, I don't know, go for a walk or something, see if I can find two identical leaves.
A good walk is always a good idea, clears the mind. But just remember, okay, even if those leaves, look identical, chances are their own unique journeys and experiences have made them different in some subtle way.
I'll keep that in mind. And to everyone listening, hey, thanks for joining us on this deep dive, into the identity of indiscernibles. It was quite a journey, and we hope it's given you all some food for thought. So until next time, keep those brains buzzing.